Welcome to lesson 15 in Saxon Math Course 3. Today we're talking about powers and roots. Our objectives for our lesson today. After this lesson you should be able to use exponents to show repeated multiplication, simplify exponential expressions, write prime factorizations using exponents, and find the nth root of a number. Some review from last time. Evaluating an expression means we're going to replace the letters, the variables in an equation with the numbers they give us and solve. And solving using inspection is using mental math to solve a given equation just by looking at the parts and figuring it out. So today we're going to talk about exponents. Exponents are the small raised numbers that show repeated multiplication. An example, 5 with a raised 3 actually means 5 times 5 times 5, which would be 125. You have to be careful. A big mistake people make is thinking that that little raised 3 is just times 3. So they would say, oh, it's 5 times 3, it's 15. No, that tells you how many 5s you're actually multiplying together. If the exponent is a 2, we read that as squared. If the exponent is 3, we read that as cubed. So that problem we just did, 5 with the little raised 3, we would say that's 5 cubed. If the raised number is a number greater than 3, then we would say whatever that number is to the blank power. The book likes to use the letter n as a missing number. So n can represent any number. So we would say to the nth power. So example 7 with a raised 6 would be 7 to the 6th power. And that means we're going to multiply 6 sevens. 7 times 7 times 7 times 7 times 7 times 7, which would be a really big number. Prime factorization, I know we've done that for a while now. Now we're going to write them with exponents instead of writing them out. So that will save some space and some time. So if your prime factorization of 72 is 2 times 2 times 2 times 3 times 3, that's how you've been writing it so far this year. We're going to do that with exponents instead. So count how many times each number shows up. That's your exponent for that number. So since there are 3 2's and 2 3's, my new prime factorization would be 2 cubed times 3 squared. That's the prime factorization of 72 with exponents. We can also write variables with exponents if we have repeated variables. So just like the prime factorization, we count how many times each variable shows up. So 3x, y, 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 z using exponents. We count up each variable, and however many times it shows up, that's the exponent for that variable. So x repeats twice, y repeats 3 times, and z is only there once. So the answer would be 3, which stays the same. There's only one 3. There's 2 x's, so x squared. 3 y's, so y cubed. And then z, you could put a little 1 above z, but that doesn't really mean anything. It just means there's one z, so you don't have to put anything. Now we're going to talk about radicals. Radicals are the opposite of powers. And we show those with the radical symbol, which we also call the square root symbol. So here's an example, square root of 4. The 4 is known as the radicand. Whatever number is underneath the sign, we call the radicand. And as I said before, you would read this as the square root of 4. And if we want to show the relationship between square roots, or I should say radicals and powers, you could rewrite square root of 4 as question mark unknown, we don't know, squared equals 4. So whatever number squared equals 4 is the square root of. There are other radicals besides square roots. For example, here's a cube root of 8. Notice the little the little 3 we have here makes it a cube root. The little number above the radical symbol is called the index, and in this, the 8 would be the radicand. We could rewrite this if we wanted to solve it as something cubed equals 8. So what number do we know times itself 3 times equals 8? The answer would be 2, because 2 times 2 times 2 is 8. We're also going to talk about perfect squares. Perfect squares are numbers that have a whole number square root. So the first 3 perfect squares are 1, 4, and 9, because 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So if you do the square root of 9, it's 3. That's a whole number square root. That's why 9 is a perfect square. You could think all the way up to probably 144 or 169 if you know 13 times 13. Those are all perfect squares. That's all for your lesson today. Make sure you do your practice problems. Put any questions that you have on the discussion section so we can talk about them. Your next assignment will be a test, so we'll see you in lesson 16 after the test.